outside. Out.
Okay. Good afternoon, everyone. Can you hear me?
Yes, sir.
Yes, sir.
So only 9 of you are present at the moment. But kindly remind your uh, classmates that majority of the class has to attend, okay, so that the link to the recording might be sent to all of you. But anyway, we will have what they call this composition of functions exercises on composition of functions and applications of functions. There are two on applications. One is functions as models, where we use piecewise functions to model word, world, or word, or even world problems. But for this session, I will be only doing optimization, another application of functions. Okay, so let's start with that exercise there, where you have to find the domain of a composition, f of g and g of f. Now, by the way, what does f of g mean? What does this symbol mean? F circ g. From the word circle, so f circ g, or just read it as f of g. What does that mean? Anyone? Yes, it is g of x. By definition, these two are the same thing. But what does this mean? Anyone? That composition there, where you have a function inside a function. Note that g here is the inner function, and it is inside the outer function, which is f. So what does that mean, and how do you evaluate that? Anyone? For example, okay, let's have f of g at 1. How do you evaluate this one?
Sir.
Yes.
Sir, we plug in 1 in G, and whatever answer we get in G, we plug in f of x.
Okay. So you first evaluate 1, or the inner function of 1. So given the function formula, that would be 1 squared minus 1, or 0. And then the result of g of 1, or the value of g of 1 in turn, is plugged in to the other function f given by this formula. So that would be f of 0 equals 1 over 0 minus 1, or negative 1. So that's f of g of 1. Okay, evaluate g of 1 first, then the result, evaluate into, or substitute, plug into f. Now let's get the expression or the formula for the function itself, f of g of x, not at a particular value like 1, but at a variable like x. Okay, of course, you can use any other variable to denote the formula, like t or s or any other letter you prefer, but usually in mathematics, we use x to denote the independent variable. So how do we express f of g of x in terms of the variable x? How do we do that? Anyone? Okay, 1 all over x squared minus 1 quantity minus 1. So instead of using a number, you're using a function to plug into another function. So here is f of x. And here is g of x. You're going to plug in g into f. And that means every occurrence of the variable x in the formula for the outer function f must be replaced by g of x, which is this one. So that would become f of g at x would become 1 all over, replace this one by this one, x squared minus 1 minus 1. So that would be 1 all over x squared minus 2. This is your f of g of x. So we have it in one formula instead of having to do it one step at a time, like what we did a while ago. We evaluated g at 1, and then g of 1 we plugged into f. So this one gives us already the formula for obtaining the composition. So instead of having to do it in two steps, you just do it in one. So again, f of g of 1 would be 1 over 1 squared minus 2, and we obtain the same thing, negative 1. But there's actually the question of the domain of the composition f of g. So we got, again, f of g of x equal to 1 over x squared minus 2. And we discussed domain before in the very first session, I think, on module 3. And all you have to do is observe, okay, if there are any roots or any divisors. In this case, there is a divisor, there's a denominator. So it cannot be 0. That means the domain would be the set of all real values satisfying this one. X squared minus 2 is non-zero. And all you have to do is solve that as though it were an equality or an equation. Okay, and x squared not equal to 2 would be true if x is neither plus nor minus square root of 2. So that's the domain for f here. And in set notation, remember, we have to use, to call this brackets or braces. So we read this as the set of all x such that, okay, x is not equal to plus minus square root of 2. Okay, how about g of f now? Are they the same function? Well, obviously, from the way they are written, they are not identical functions, since for the second, it would be the f now, that's the inner. Okay, this is always the inner, the rightmost one. Okay, if you have a series, of course, of functions, then the rightmost one would be the innermost function. That's the one that has to be evaluated first, then f, then g. So this time you will be, for g cert f, you will have to evaluate f first. You have to plug in x first into f, then the result you plug into g. So for example, we want to evaluate g at f of 0. So what you do first is evaluate f of 0. So plug into f, not g. So that would be 1 over 0 minus 1. That's negative 1. And then the result, plug into the outer function, this time g. So g of negative 1, plug in here, would be negative 1 squared minus 1. So that would be 0. Okay. Now, if we evaluate f of g of 0, we won't necessarily get the same value, as we shall see. So for this one, it would be f at, okay, you evaluate g of 0. So that would be 0 squared minus 1. That would be negative 1. So this is f of negative 1. And f of negative 1 is 1 over negative 1 minus 1, or negative 1/2. So you see that they are not the same. G of f of 0 is different from f of g of 0 because of the order in which you evaluate the composition. So again, let's get a formula, one formula for the composition g of f. And this time it is the f that has to be plugged into the g. So this is your f. You plug it into g for every occurrence of x there. So this is your g of x equals x squared minus 1. And we will replace this x by this whole expression. So we have, okay, g of f of x. So we replace x by f of x. We also replace this by f of x, or this formula. So that would be 1 all over x minus 1 quantity squared minus 1. And the rest would just be a matter of simplification, unless otherwise specified that you don't have to simplify, especially if like you have a very big exponent there. So obviously you won't be required to simplify, since that would take a lot of time, and moreover probably you won't get the correct answer anyway because of the too large an exponent there. But if we do so, if we simplify this one, remember, yes, last time, I think it was in another section where we discussed evaluation of functions. So you have to square this one. Anyway, it's just algebra. So 1, you square 1, that's 1. You square this one, that's x squared minus 2x plus 1. And then LCD. And then simplification gives negative x squared plus 2x all over x squared minus 2x plus 1. Okay? So let's answer. What's the domain of the composition f of g? Anyone? What's the domain of that? Actually, you need not look at the simplified form. You just have to look at the what they call this immediate what they call this expression obtained by substitution of f into g, which I mean is this one. So you just look at that. For that to be defined, what has to be required of x? Obviously, there's only a denominator, so you just have to require that these be defined. And for that to be defined, the denominator should not be 0. So instead of looking at this one, it would be much simpler or easier, quicker to look at this expression. So right away, you can tell x should not be equal to 1. Of course, you can also see it from this expression here after factorization of the denominator, which is x minus 1 squared. And eventually, if you set that not equal to 0, you will also conclude that x should not be equal to 1. Okay, any questions so far? Okay, yes, that's correct, Mr. Samson. Not equal to 1. Okay, next. So I think I'll give you 5 minutes first before we answer this one for your practice. let's have f of g. Plug this one into x. Okay, and that already is f of g. So it remains to find the domain of that. But in order for the composition to be defined, g of x must first be defined, of course, which means that this expression inside has to be taken into consideration. There are two radicals, one outside, one inside. So both radicals have to be defined. So let's consider the inner radical first there. So for this to be defined, it's the expression inside it should be non-negative, which gives us 2 plus x greater than or equal to 0. Also, the expression inside the outer radical must be non-negative, which gives us the inequality 2 minus square root of 2 plus x greater than or equal to 0. And then what you have to do afterwards is solve the two inequalities and then take the intersection, since both have to be satisfied in order for the composition to be defined. So let's proceed to the solution of those inequalities. The first one is easy to solve. 2 plus x greater than or equal to 0 would imply or would be equivalent to x greater than equal to negative 2. Okay? Madali lang yan, syempre, ano? But the second one might be a little tricky because it involves a radical, and your tendency would be to perhaps square. Okay, what I mean is this. Mag-i-square kasi tayo mamaya eh. Okay, let me first proceed with transpositions of this inequality. Let me transpose, say, this one to the other side. What we'll have is this. Or we can rewrite that as simply square root of 2 plus x less than equal to 2. Okay, you interchange their positions. You also have to reverse the sense of the inequality. Now, tendency is to square both sides, although in this instance, it would be mathematically correct. But it's not always the case that squaring would result in an inequality of the same sense. What I mean is this. We know that negative 4, for instance, is less than or equal to negative 3, correct? You agree? Is negative 4 less than or equal to negative 3? Yes, because it's in the negative. They are both negative numbers. So the more negative, the lesser it is. But if you square both sides, notice the inequality will no longer retain its sense. It will no longer be true. I square the left-hand side, I get 16. I square the right-hand side, I get 9. But it's not true that still 16 is less than or equal to 9. It only is true, it can only be applied, squaring both sides can only be applied if both quantities are positive. Like if you have 2 less than, or say 4 less than 3, both are positive, therefore you can square both and retain the sense. Okay, but not if one is negative. It will not always be the same in its sense if you square. But do we have both positive quantities here? Obviously, this one is a positive quantity. How about the other expression? Is it always a positive quantity, or could it be a negative quantity also? Yeah, it may seem so because you know that the square root of a number could be either the positive root or the negative root. But as explained in a previous session, when we want to indicate the negative root, we put a square root, a negative sign before the square root. So when you write in mathematics square root of 4, you don't give both. You don't say, okay, so let's say your teacher asks you, what is the square root of 4, sir? 2 and negative 2 wrong. So the square root of 4 is only 2. Unless you're being asked to solve for all values of x that satisfy this. Find all values of x such that the square of x is 4. Then you give 2 values, plus, minus 2. But when you just have this symbol here, the root operation, the square root operation, you are meaning the principal root, which is the positive one. If you want the negative root, you have to put a negative sign before the radical so that you get the negative of the root. Okay, so square root of x means the positive, okay, the principal root. Students still get confused on that, okay, whether you mean both positive negative roots or just the principal root. So the principal root again is the positive root, okay. So if you want to mean the negative, what do? You put the negative. So here, if I want to mean the negative, I have to put a negative sign. But since there is no negative sign before it, you mean the positive root. So this one, in other words, is always positive. Of course, in general, the square root of x, where x is a real number, is non-negative. So since they are both positive, we can solve this inequality by squaring both sides now. I square the left-hand side, retain the sense, square the right-hand side, solve for x. We get this. X less than or equal to 2. So now we combine both, get the intersection, and it should not be hard to see that the intersection is the closed interval from negative to 2. So this one here. So domain, closed interval, negative 2, 2. Okay. I'll leave the other one as practice, since you already know how to do part A. To do part B would just be the same. Okay. So anyway, let's proceed to the next one. Okay, again, you're given two functions f and g here. You're going to find the domain of the composition. And let us first answer letter B this time. Okay, letter B. Let me already show you the solution for letter B. First, let's evaluate g of f. Now we plug in f into g. Okay, f is the inner. So f into g. There. And of course, if you are required to simplify, or to simplify is in the directions, then this expression would become as follows. Okay, and further simplification gives this one. So x minus 2x is negative x plus 2 there over x minus 1. So this is your g of f. Now, question, how do you get the domain of that? How do you set up an inequality that will give you the domain of the expression? There is a divisor and there is a radical. So what are the inequalities involved here? Anyone? X minus 1 is not equal to 0. Of course, that should be set to ensure that this is defined, right? The expression inside is defined. If the expression inside is not defined, then the square root of that would also be undefined. Another one. There. Negative x plus 2 all over x minus 1 must be greater than or equal to 0 because of the presence of a radical outside. So you have to also solve this one. Although in the solution of this one, actually, we would also be including the solution of this one. Since in the construction of the sign chart, you have to put an ND for the partition number given by that factor x minus 1. So, di ba sign chart ang ginagamit dito? How do you construct the sign chart or table of signs kung mas convenient kayo doon? So, di ba partition numbers come from the zeros of the factors present. So, we have 1 from this one, and then we have from this one, if you equate this to 0, you have 2. And then you put those partition numbers on the real line, and you pick a test number for each subinterval, and whatever the sign, remember, will be the sign of the entire interval. So doing away with those steps, let me just give you the order of signs from right to left. It would be negative, positive, negative. And of course, dito pala to. You also have to, by the way, put a 0 or an ND on top of each partition number. So where do you put the 0? The zeros of the numerator. So you put the 0 on top of the 2, and then for the zeros of the denominator, you put ND. And right away, that ND there excludes 1. So, but it's safe to also include this inequality in your observation, that one cannot be 0 because you cannot divide by 0. And if you write the solution for this one, it should be greater than or equal to 0. So you will be excluding 1, but you will be including 2. You excluded 1 because it's ND there. And then no need to further exclude 1 because it has already been excluded. So that already is the domain. Now, there could be problems when we evaluate the domain. Ito yung gusto ko kasing ipunto. There could be questions, so listen carefully. There could be questions in the midterms. Piniprepare ko na rin kasi kayo sa midterms, kaya puro exercises talaga tayo. Tapos hanggat maaari, dahan-dahan lang tayo sa topic. No? So siguro I will stay on this topic na lang, composition of functions. But let me give, sagutan nyo na lang yung letter A na for your practice. Let me give two functions here. F of x equals 1 over x minus 1, and g of x, say 1 over okay, let me click this way. Okay, yan. Pwede na yan. Now, binigay ko to so that you can see that sometimes you cannot get the domain simply by simplifying right away the composition. So let me explain what I mean. So suppose I want you to find the domain of, say, g of f. Okay. The tendency is, of course, to first evaluate g of f. So let's do that. G of f would be equal to, you plug in f into g. So this one into this one. So you'll get this, 1 all over x over x minus 1. And of course, you will naturally simplify that one as x minus 1 over x. And then if asked for the domain, you just conclude, oh, the domain is set of all x not equal to 0. And you get a wrong answer. Why is that? Anyone? Why is this a wrong answer? Well, if you look at the final expression, it seems to be correct, but it is not. Would anyone explain why that is not the correct domain of the composition? Anyone? Pwedeng mag-unmute or pwedeng mag-explain sa chat box.
Sir, before
Yeah.
yung denominator na x over x minus 1, you should take into consideration yung x minus 1.
Yes. Okay, correct. Nice observation. Note that what we have here is already the simplified version. After we have evaluated a series, okay, of substitutions or evaluations. Actually, for this one, we have to evaluate f, and then after that, we have to evaluate g at f. So what if in the first place, when we evaluate f, we no longer have a defined value? Okay, so kanina kasi di ba sabi natin, ang domain lang naman niya x not equal to 0. But actually, hindi rin pwede yung 1 sa domain nito. Why? Let's see. What if we have g of f of 1? Sabi kasi nito, 0 lang ang i-exclude natin. But if you evaluate g of f of 1, first you have to evaluate f of 1, right? Now, we plug in 1 over 1 minus 1. We get 1 over 0. Undefined. Correct? So that means, hindi na rin defined yung composition because yung inner hindi defined. Well, kung binaligtad mo yung 1 over 0, akala mo makakakuha ka, di ba, ng defined. Well, defined naman na pag binaligtad, di ba, i-reciprocal mo nga si 1 over x, di ba? Si x doon. But of course, the reciprocal of 1 over 0 is not 0. Okay? Kasi undefined yun eh. Walang reciprocal yung undefined eh. So tama yung observation niya. Before you give, okay, the domain of a composition, you have to observe the original statement or rather expression. Huwag muna titignan yung final expression. Sometimes, para maging defined yung final, kailangan maging defined muna yung original expression. So how will this be defined? If we look at this one, it will be defined if, of course, the denominator is defined. Kapag hindi defined yung denominator, hindi siya defined. So, paano magiging undefined yung denominator? If the denominator of that is 0. So we must have this. Okay, and then you can take a look at the simplified form now and make a further observation that, oh, this one will not be defined as well if its own denominator is 0. So we have to add this. Pero makukuha nyo rin yan, ano, dito mismo. So again, we observe this has its own denominator. So x minus 1 is not equal to 0. And again, observe this one. It has a denominator. Diba ano yung denominator ng buong fraction? Complex fraction kasi ito, ano? But this is a denominator, the expression in the denominator of the bigger fraction, say. So hindi pwedeng maging 0 yung denominator sa denominator. Diba? I mean yung expression na ito sa denominator. And if you cross multiply that, you will also get x not equal to 0. So the domain is the set of all x values such that x is neither 0 nor 1. And the more convenient way, again, of writing that one, please study the video. Set of all real numbers except, then you use the set notation, put all those values to be excluded. There. Yes, it is best to get the domains of the initial functions first. So kunin mo yung domain ng inner. Yan yung usually ginagawa. Sisiguraduhin mo yung inner defined. Once na nasigurado mo na the inner one is defined, then that's when you also take a look at the final expression, the simplified form. Ano yun? Ano? 1 all over x over x minus. So in short, this is defined. Patanggalin mo si 1. Diba? And then, evaluate mo na si f of g. Ito na yon. Simplify mo na si f of g. Ensure mo rin na defined yan. So exclude mo si 0. At siguro, try natin yung f of g. Can you give me the domain of, sige, pareho lang ang lalabas doon, no? So let me give another one. Okay, sige, 5 minutes. Give me the domain of f Okay. So anyone got an answer? What are to be excluded in the domain? No one? You can type in your answer. Nothing? Okay. 2 and 3 helps. Okay, correct. So first, the G has to be defined, right? So if the G is not defined, then the composition itself is not defined. It makes no sense to evaluate f of G when G has no meaning or is undefined. Now, observe G. It is undefined if X is not true. So you have to take note of that. X cannot be equal to 2. But it doesn't mean also that f of G is defined. G could be defined, but f of G itself is not. So that's why we also have to evaluate the composition. So f of G of X, evaluate it. So plug in G into F. So for each occurrence of X, you will have to plug in the whole expression for G. Okay, X over X plus 1. That's your X over X plus 1. And you simplify this one. And how do you simplify this one? You use the least common denominator, which obviously is X minus 2. So multiply by X minus 2 over X minus 2 to read the expression of complex fractions. So we'll have X minus 1 all over, and then this one, X minus 2 cancels out. So we have another X minus 1 and then X minus 2 times 1 has to be distributed, okay? So you'll have plus X minus 2. So we'll have this one, X minus 1 all over 2X minus 3. That's the composition. And the composition will be undefined if 2X minus 3 is 0. So you have to set 2X minus 3 non-zero, so X not equal to 3 halves. Okay, that's only for the composition. But again, since it's a composition, both the inner function must first be defined, so you know you have to exclude, which is not evident from the final expression here. So domain is set of all X, set of all real numbers such that are not equal to 2 and 3 halves. Okay, is there any question for your practice? You may want to try G of F. That's for your homework, and as well as the set of practice exercises I have uploaded in Canvas. So if there are no questions, wala, no? So that's it for this session. We end the meeting.